The other type of solving a log equation is when every single term has a log on it, okay? So what I would do then, if I need to condense the logs, meaning that maybe I have multiple logs on one side of the equation. So what I really need it to look like is I have the log on one side and I have the log on the other side of the equation. So once I've done that, I now get to use the property that same bases cancel. So I'll cross off my log and its base, and then I'll continue to solve. Remember, always checking in the end to make sure that my solutions give me a positive answer. Not that the solution is positive, that when I plug it back in, that I get a positive answer. All right, so let's look at a couple examples here. All right, let's say that for our first example, we have log base 7 of x plus 7 minus log base 7 of 2 equals 2 log base 7 of x plus 1. Right? So what I notice about this is that I have a log on every single term of the equation on both sides. It's everywhere. So in this scenario, what I want to do is I want to make sure that each side of the equation only has one log. It's condensed as possible. All right, so what we're going to need to do is use those condensing properties that we have looked at for logs, where subtraction ends up being division. So let's do that. So I'm going to have log base 7 x plus 7 divided by 2 equals, remember in condensing, this 2, or the number in front, is now going to become the exponent. So it's going to be log base 7 of x plus 1 squared. So now what I want to do here, since I have the same base, I have a log base 7 and a log base 7, I get to now cross those off. Same bases cancel. What that means is now I'm going to have the equation x plus 7 divided by 2 equals x plus 1 squared. Now this is a more simple equation to solve, so I'm going to go ahead and solve it here, remembering that if it's squared, that means I have to write it twice and distribute it. So distributing that, I would get x squared plus 2x plus 1. All right. Now, I see over here we're dividing by 2, so I'm going to need to multiply everything by a 2. So I'm going to have x plus 7 equals 2x squared plus 4x plus 2. I'm going to need to set it equal to 0. So I'm going to subtract a 7 and subtract an x. So I have 0 equals 2x squared plus 3x minus 5. All right, now from here, I'm going to go ahead and factor this. So when I go to factor this equation, I'm going to end up with 2x plus 5 and x minus 1. Now, remember, you can solve the quadratic however you want. I typically like to factor only because I'm very comfortable with factoring. You could have done the quadratic formula if you wanted to, but it's definitely up to you. So remember, if I want to continue to solve, I would set each of these equal to 0 and solve it. So I get 2x plus 5 equals 0. So solving that, I'm going to subtract my 5 and divide by my 2. So x should equal negative 5 over 2. Doing that to my other equation, my other factor gives me x equals 1. So we think that these are our two solutions, but we're not sure because we have to go check them. So we think these two work. So let's check. Let's first check my x equals 1. So I would go back to each of these logs and I'm going to plug it in. So I have 7, or x plus 7. So 1 plus 7 is indeed positive. 2, there's not even an x to plug in, so it's for sure positive. And then I have x plus 1. So 1 plus 1 is also positive. So this x is equal to 1 works. So let's check our next one. So we're going to check x equaling negative 5 over 2, which is the same as negative 2.5. Sometimes it's easier for people to use the decimal. So let's check it. I've got negative 2.5 plus plus 7, which is positive. That 2 is still positive. All right, so it looks like it's working. But then what happens when we get to this next one? We have negative 2.5 plus 1. That is negative. So this actually does not work. It is not a solution. So we have to make sure that not only are we checking both solutions, we're plugging them into all of the logs and making sure that it works. It either works for everything or it doesn't work at all. So what we find is that x equals 1 is a solution, and x equals negative 5 over 2 is not a solution. Instead, we would call that an extraneous solution, because what happened was we got it when we were solving. However, it actually did not check out to work when we went and plugged it back in. All right, so let's look at one more example here. See if we can move this off to the side here. I can get another example going here. All right, so let's try another one. Let's say that we have the equation log base 6 of 2x minus 3 plus log base 6 of x plus 5 equals log base 6 of 8x. All right, so now that I notice I have a log on each of my terms, what I need to do is I need to condense anything that I can. Now my right side is already condensed, but my left side, I need to turn that addition into multiplication using that product property. All right, so now I'm going to have log base 6 of 2x minus 3 times x plus 5 equals log base 6 of 8x. All right, now that I have a log base 6 on both sides and they are by themselves, I'm going to go ahead and cross them off. So I now have 2x minus 3 times x plus 5 equals 8x. I'm going to go ahead and distribute now. So I'm going to distribute. I get 2x squared plus 10x minus 3x minus 15 equals 8x. So I get 2x squared plus 7x minus 15 equals 8x. Now, since this is a quadratic, I need to set this equal to 0. So I need to go ahead and move that 8x to the other side. So I have 2x squared minus x minus 15 equals 0. Now, again, I'm going to go ahead and factor this. But that's because, I liked factor. So I'm going to have 2x, plus 5, and x minus 3, excuse me there. All right. So now that I've factored 2x plus 5 and x minus 3, I'm going to set each factor equal to 0. 2x plus 5 equals 0, and then x minus 3 equals 0. I'm going to solve each one, so I subtract my 5, divide by my 2. So x is going to equal negative 5 over 2. I'm going to add my 3, so x is going to equal 3. So now I think that these are my solutions, but what I'm going to have to do is I'm going to have to go back and I'm going to have to plug it into each of my logs. Okay. So let's first say that we want to check x equals 3. So I'm going to have 2 times 3 minus 3, which is indeed positive. Then I'm going to have 3 plus 5, which is indeed positive, right? I don't care what the number is, I just care that it's positive. 8 times 3, which is indeed positive. So that means x equal 3 is a solution. All right, let's try negative 5 over 2, which again we said was negative 2.5. So let's try it. So 2 times negative 2.5 minus 3. Oh, that's negative. So I don't need to continue. I could, but I don't need to continue trying these, because if it doesn't work for one, it doesn't work for any of it. Although I'll go ahead and show you so you can see. So I'd have negative 2.5 plus 5. That one's positive. And then I'd have 8 times negative 2.5, which is again negative. So since I got negative here, that is not an actual solution. That's what we call an extraneous solution. So the only solution that's real here would be that x equals to 3. So when I'm solving a log function where I have logs on everything, I need to condense both sides first if it can be done. Then I'm going to cancel off the logs, continue to solve, making sure that I check my solutions in the end to make sure I don't have anything extraneous.